is a function? In English, a function means a factor, which is related to or dependent upon other factors. For example, my GPA is a function of the hard work I put in during the semester. The more hours I put in, for example, the higher grade I get. So suppose we have two sets, a first set and a second set. If each element in the first set is mapped to a particular element in the second set, then that is a function that shows the relationship between the two sets. You can also think of a function as a machine, such as a computer. When you feed in the input x and crank it through the computer or the function machine, the program will generate an output for x. For example, feed in x as the input, run it through the squaring function, and out pops the output f of x, which is equal to x squared. As another example, feed in an integer k as the input, run it through the successor function, and out pops the output g of k, which is equal to k plus 1, which is the next integer, its successor. Here are two more examples. If x is the number of inputs in your program, and your computer algorithm has an execution time that involves the logarithm function of the input size, then the output f of x, or the execution time, will be something that is rather efficient and manageable as the data size gets larger. On the other hand, if x is the number of inputs in your program, and your computer algorithm has an execution time that involves the exponential function of the input size, then the output f of x, or the execution time, will be something rather inefficient as the data size gets larger. So these two functions will be of special interest to computing science in the study of the efficiency of algorithms later on. Don't forget, though, that the computer is, after all, a hardware. It still relies on the software and the human touch to manipulate the software in order to make it work for us. That is why it is important to understand functions and the mathematics behind it so that we can manipulate the software well to get programming outputs that make sense to us. The objective of this topic is therefore to have an in-depth study of functions. We start by defining a function and understanding what qualifies to be a function. We then look at properties of functions such as one-to-one, onto, and inverse functions. We will also look at how functions interact with one another to form composite functions. Special focus on commonly used mathematical functions will be given, with particular attention on the exponential and logarithm function. And we end the topic with an application of the pigeonhole principle.